but it worked better if I do something slightly different than this. So with your permission, I'd like to spend a little more time on this. You can see the answer is A to that one.
Yeah.
The other thing you can do is test points. But let me just show you some pretty basic. Let's just say we had y greater than x, okay? And then we have x greater than 0, and then y less than 1, okay? Where is the overlap?
It's going to be in the just in the top right there.
Kind of hard. It's here, but it's kind of hard to see, right?
Yeah.
Now, if I flip all of these, oops, did I not flip that one? I don't think I flipped that one. No, I did flip it. And then now I think it's when you flip the inequality signs, it's a lot easier to figure out where the intersection is. It's that white. So consider that when you're graphing, you may want to graph the flip of the inequality to better determine where the shading is.
Gotcha.
All right, so lesson is over on at least on 114, especially if you're allowed to use a tool like the one we just talked about. So the answer to 6 is A. For 7, what I'd like to do is maybe test points, but it's not faster to graph. Like, I don't, I had to push a car into the garage today, and it's a lot easier when you can drive it and rather than pushing. And testing points is like pushing a car. It's like you got to test a point in every single region until you get the right answer, and you have to test it in both, and you can't make any mistakes. So it's your choice. Do you want us to test a point in every single region until we find it? Do you want us to graph it? What would be best to help
probably graphing.
Okay, so why don't you graph this and tell me however you want to tell me the correct answer, A, B, C, or D. I'm going to do the same, but not share it, and you can we can discuss if we're different in terms of our answers.
Let's see. I did want to ask you on a graphing calculator. There's the one that does most. How do you make the greater or less than, or well, sorry, I know that, but like and equal to, like for example,
you type in the greater than or equal to, and then you hit the equal sign, and it will automatically convert to that, or the less than the equal to. You can also go to the keyboard and find it.
Okay.
If you're really, I'm big on just trying stuff, so I didn't really, well, that kind of seems intuitive, and I try it. So these are good things to consider.
So I got it calculators. Let's see, it's kind of like
A, B, C, or D.
Yeah. Oh, okay, gotcha.
You just have to choose. This one's actually not drawn well because you don't see the intersection of where this comes back up.
Okay, so I'm trying to figure out where they intersect.
Where the overlap is.
Okay. Right here, it looks like that's around -7 and 9. So
okay, so just to be clear, you're not looking for the intersection. You're looking for. Let me make sure I'm actually sharing what I think I should be sharing. Yeah, you're looking for which region is both shaded.
Oh, okay. A then.
Yes. A is your, okay. And then you can do the same thing for 8. For 8, I can't read the second one. Is it y greater than or equal to x?
Give up my book.
This one looks like you might have moved the picture away before it was finished. With the circle thing that it kind of goes around when you're scanning.
Okay, 114 from 8. Okay, so x squared plus y squared smaller than or equal to 36. Now y is greater or equal to x. Yep.
Okay. So why don't you graph that?
Okay.
Let me know what you come up with.
All right. So the overlapping area is going to be B.
There's B. Very good. All right. Okay, so should we do the usual here where I kind of pick some problems, or
Yeah,
do you have some
yeah,
other things
whatever
that
you
you
think
would?
would be most helpful.
Okay, so I mean, I know that we've skipped some lessons since we've last, or you've done some lessons since we last have met here.
Yeah, our
Um,
class doesn't do every single lesson, but the important ones.
they're all important though.
Well, yeah, I
Okay,
got you.
all right, that's all right. So actually, what's kind of neat is you can do a problem like 14 on Desmos, a
Mhm.
calculator. Why don't you try it? Well, and I'm going to do it as well and snip in the results.
Okay.
But it's really not any different than what we've been doing. You have to know how to interpret the tool that you're using. You can't just think,
Mhm.
oh, it's just going to give me the answer. You know, computers are only as smart as the person that's using them.
Yeah.
So if you don't know how to use it, you're not going to get what you want.
So, is that going to be? Um, all right. So is that just going to be -4? Uh, let's see. This would be better represented by a line.
Well, yeah, so there's this is if you just graph it as is, right? That's one way to do it. The better
Yeah.
way to do it is to graph y equals x squared, and then y equals minus 3x plus 4. And then to interpret what this greater than or equal to means, it means where the one on the top is above the
Mhm.
one on the bottom.
Okay.
Okay, so now I'd like you to try to graph that. And that's kind of you got to be very careful when you use these tools, because so easy to not really know what the answer is or why
Mhm.
it's the answer. And so let me snip this in. All right, so here when I snip this in, you'll see this now. We're basically asking where is the red above the blue?
Mhm.
And it's above the blue from minus infinity to -4, and then 1 to infinity.
Mhm.
But how do we get that from this? Well, it's the shaded region, but you have to recognize that it goes to minus infinity to infinity.
Mhm.
Alternatively, we could solve it a different way, like we could use factoring stuff. There's a lot of ways to do it. I guess I just wanted you to see that this tool is pretty powerful if you know how to use it or want to learn how to use it.
Yeah. For some reason, our teacher in particular is very she does not like graphic calculators. However, she says that we can use them. It's just that she gets like she's kind of like, annoyed if we do it with the calculator, but she says, she's not gonna like remove our grades for using it or anything like that.
Yeah, you gotta always give them what they want here. So
Hmm.
I don't know, they does say to graph on a number line so that your answer, the Desmos, actually the original is kind of better, because you can say, okay, that's -4, that's 1, you're shading in,
Hmm.
filled in, shading in.
Yeah. So that would be basically from 1 to -4, or sorry, rather the opposite. That's 1 and all the way to the right, and then -4. Yeah. Yeah.
It's read left to right, minus infinity to -4, comma 1 to infinity.
Hmm. All right. Very well.
Okay, so 15, 16, 17. Why don't you pick, I want you to use 16. That's got some, and try the Desmos calculator again.
Okay. All right. Let me just get wrapping paper. Okay. Okay, so um okay, so it's gonna be from -10 to 10.
I have something. We're talking about 16.
Yeah. Um let's see. Oh
Is your
wait.
graph?
Oh yeah, that's 4. Okay, that makes sense. Yeah, I was just doing it manually. So
So this is
-4 to
every.
4.
Yeah. Now, I should point out that it's very explicit here that it is only the set of integers. So it's not like our last answer kind of isn't correct
Mhm.
because we can, and this one I'll just give you more specific. It's -3, -2, -1, 0,
Yeah.
1, 2, and 3. Whereas the other one is all the integers except for the ones from -4 to 1. Like you would say it's the set of integers z slash, I don't know if you use this notation in your course.
Mhm.
That means take away, like
Okay.
remove these from it. Maybe you aren't using that, but you're supposed to say it's all the integers except for those.
Mhm. Very well.
Okay. So I think that's enough for those. Um, let's see here. 9 and 9 and 10 we should look at. All right, so let's look at 9a. It says to find x. I guess you have to calculate. It really should say calculate x. X is already calculated though, and
Mhm.
this one. You could go to a calculator. Like you'd at least try that, and they'll give you. Let me see what to round to. Maybe round to 2 decimal places. I'll say.
Yeah, that's what we do in our class.
Oh, good. Good.
-4.77.
Yes. Okay. Very good. That's 9b is kind of more of what you would expect to see for test or quiz question. So you have to know how to undo how to get a variable out of the exponent. Do you remember anything about ln?
Logarithms.
Logarithms, yeah.
I'm a little bit confused as to like, oh, it would be beneficial if you could explain those a little bit, but
Sure. Okay, so we got to go backwards a little bit. Their logarithms are a manipulator of things. They have a base, and they're the thing you take the log of. So this is the base. This is the thing you're taking the log of. If you look at a graph of log, it starts like this and then goes to the right. It goes up very, very slowly. So when you're charting big data sets, you sometimes will see that the log is used on one of the axes to graph it because it scales better. Because if you imagine like graphing something that's over, I don't know, 1,000 years and not much is happening, you kind of can compress that. But
yeah,
these are just manipulators, and basically you're using them to deal with exponential functions.
okay.
So they all go together, meaning like you know that addition is undone by subtraction, multiplication is undone by division. A squared is undone by square root. So if you have something for the power of x, you have to have a way to undo it. And that's
Mhm.
what's happening here. There's more to it that can't be explained at this point. But most of the time, you can think of logs as having a base, some sort of base, like, and the most common one is base 10. But you'll see a lot of problems where the base is 2, or the base is 3.
Yeah.
And this is actually related, somewhat related to, like, in the programming world, different bases of looking at stuff, looking at numbers. Maybe you've heard of binary, hexadecimal. We've run in base 10 decimal. There's some relationship there, not a ton. Now, the one that you see a lot of is log base E. So for a long time, log base E wasn't really used, but now it's kind of become the standard, and it's been shorthanded to ln. Log base E is ln. And so whenever you're trying to get a variable out of the exponent, you use ln, because there's some properties, they call them logarithm laws, like the 10 law. Yeah, they're laws, I guess. They're really just properties that work. But we use these to, like, undo things. I don't know how much of this is helping, but let me know when you want us to go back and maybe look at the problem again.
Mhm.
We'd have
So,
to
okay, sorry. Good.
we'd have to do a whole kind of a whole lesson, because there's also kind of this graphical stuff, which is like, if you have a growth function like that,
Hmm.
it always has an inverse, and the inverse is ln of x.
Okay.
And similarly, if you had a function like 2 to the x, its inverse is log base 2 of x. And these coexist, like, you can't have one without the other, but they're presented separately, but they go together. You have to have them, because you need a way to undo one or the other.
Okay.
But it's a made up thing. I mean, there's not, it's not like it's a man-made thing. Logarithms,
Hmm.
they're just like another function. They're like sine, cosine. They're just something to represent something else.
Yeah. Although I do disagree with the concept that all math is made up. I think that's silly because, you know, I just, I don't buy the whole claim that everything, oh, it's just made up. And because you see this across cultures, Babylonians had math, and all sorts of different nations had math. And so I think that's a universal thing. Although I'm not going to deny that some stuff is arbitrary.
Well, we're just trying to give you, like, some, like, I'm
Mhm.
trying to explain, like, what, like, log doesn't really mean anything. It
Yeah,
means
yeah,
something in this context, and that's it. Like,
yeah. Mhm.
it's a reduction of something else that really can't be explained
Yeah, 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 exactly.
at
Yeah,
this point.
I'm just saying that uh that's not the way it is with all math.
Right, right. There's some universal things here. So we're trying to solve this problem. B here. Let me go back in it. So
Okay.
because the base, you have a base that's an E, you undo it. You undo this with log base E to the X. But shorthand, sorry, I have to take the log base E of both sides. The shorthand of this is that we've shortened it to at ln. Ln is log base E. It's easier to write. I don't know if that played into it, but, like, if you were to talk to an engineer from, I'll say, 70 years ago, they would not have used ln. They would use logs without bases. But now the trend is to use ln's. Like, if you look in really old textbooks, you don't see ln very often.
Okay.
But anyway, so there's these properties of logarithms. One of them is that you can bring the exponent out in front. So this becomes x natural log of E. And then natural log of E is really 1. That's a property because they undo each other.
Hmm.
So this becomes x equals the natural log of 87.4.
Okay. and that can be calculated.
Yeah.
Okay. And for that, I get 4.47.
Sounds right.
Okay.
Okay. All right, let's look at I guess 10 and look at 10A.
Mhm.
So the only way to get to the X here is to undo ln. Okay, and in the previous problem, we undo E with ln. So you undo ln with E. So the way it looks is you use E on both sides of the equation. Is that 9.185 or 9185?
9185.
Is there a decimal point? Because this is a huge number.
Yeah,
It's
that's
like,
9185.
okay, wow,
There's
that's
no
you can't-
decimal.
okay. So E undoes ln. So this, the left side just becomes X.
Do you hear my sister singing?
I cannot.
Okay, good.
Is it any good?
Uh, of course, it's absolutely amazing, and I love it so much. Help me. Just kidding. I cannot
Okay, well, you could
grade
send her off
her
to calc.
performance.
You could send her off to count from 1 to E to the 9,185, and she'd probably never finish in her lifetime.
Okay,
It's a huge number.
sounds good.
It's like what this is like one of those, someone buying 100 bananas at the grocery store, like you were talking about
Mhm.
a couple weeks ago. It's like ridiculous.
All math problems are, or the kind that like, such and such bought 1,000 cars one day.
All right. So the log when no base is written is log 10. There's really a 10 right there that should be written. It's very similar to like reminding yourself that there's really a 1 in front of X, and it's really to the power of 1, and it's really divided by 1, and there's really a plus
Mhm.
0 here. There's a lot of things that are unwritten that we presume to be true. So to undo log base 10, you use 10 as a base here, and you do this on both sides of the equation. So on the left here, this undoes the log base 10.
Uh,
And so the property is b to the log base b of x becomes just x.
okay. So then calculate the log of
X on the,
3.188.
yes.
Okay. Hamlin, I'm in the middle of a class. Can you please be a little bit quieter? Thank you. Okay, so 0.50.
10 to the 3.188 is much bigger. It's
10
at
to
least
the-
1,000.
Oh, whoops. Okay, sorry. Misunderstood you. Okay. Yeah. It can't be right. Oh, undefined. 3
10
point,
to the 3.188.
it just
Just
says
just the just
3.188.
just the part on the right.
All right, let's see. Oh, okay, gotcha. So that's 1541.7.
Okay, yeah, it should be bigger than 1,000. 10 to
Oh,
10 to the third is 1,000. Oh, okay, here's one. Every once in a while when there's an earthquake, the scale they use is logarithmic.
oh, is that for the magnitude of it?
Yes. And
So,
so it's like a 3.7 compared to 2.7 is 10 times as strong.
so that's kind of similar to how they calculate the power of nukes.
Yes. Exactly, because the power, it's so big, you have to put it in terms of something that someone can understand. So you make a scale that's, you know,
Yeah,
reasonable.
okay.
All right. Okay, that's 111. So we need to do problem like 24 would be good.
Mhm.
I kind of like when you do these because as a reminder, you got to combine two of the three equations, and
Yeah,
sometimes you just have to combine one or two. I'm sorry, you just have to combine two equations and you get a variable. But go ahead and take a look at this.
that's her, all right, Z equals 2. Write that down.
Yes, Z is 2, so use that to find the rest.
Okay. Okay, so I gotta solve for X. Okay. X equals -14. Z equals 2. And then, let's see. Okay. -23 equals Y.
I mean, those could be right. They seem really large, I'll
Yeah.
just say. And I mean, when I look at the first one, it doesn't work. So Z is definitely 2. I'll give you that. Which equations did you use? Did you put Z in to then find X or Y? Did you use the first and the second, or the second and the third? Because like, notice if you add the second and the third, Y goes away and you have Z, so you can use that. Maybe that's how you did find X, not sure. I think there's the mistake. I think X should have been -4. No, no, I'm sorry. +4. You are currently muted, by the way. Maybe you know that.
Oh, huh, okay, I didn't.
So we
I
kind
don't know
of
how
left
that
off where
happened.
Z is 2, X is 4. What is Z then?
Z equals 3.
Z equals 3. So that definitely sounds. I'm sorry. Z is 2. I'm sorry. What was Y? Y is 3.
Yeah.
Y is 3. Okay. So maybe try them in at least one other equation. Like the last one, I'll try like -4 plus 3 is -1 plus 2 is 1. So that looks like it good to me.
Yep. Sorry about
Okay.
that being muted. I
Oh,
don't
that's
know
okay.
how that happened.
All right. So the next problem I'm looking at here probably should have you do 22. Um, although we haven't seen one like this in a while.
Mhm.
Because this one isn't as nice as the other, where you can just be like, yep, I combined them and stuff went away. Let's see here. Well, again, you kind of have to do the brute force approach, which is just combine 1 and 2, 1 and 3, 2 and 3, and then see what happens. Maybe you notice something after you do that.
Yeah. Up this down. Okay. All right, so okay, so 2 and 3 leads to 2x plus 3z equals -2. So then simplifying that, we get
And then I think you can use the first equation alone with that one to get you can either solve for x or z.
okay. Okay. So let's see. Okay. Oops. Same. Um,
How are you doing on this one?
let's see. That don't seem right. X equals -26 divided by 11.
Definitely a little far away here. You've got these two equations though up in front of you still somewhere.
Yeah. Oh, okay. I see
I'd
what I did
multiply the
wrong.
second equation by 3. And then
Uh-huh.
that leads you to getting x equals 2.
Oh, okay. Okay, I was trying to do substitution in the first set of 3, I think.
Okay, yeah, no, elimination is kind of your friend here on these. So x is 2. And what's nice, once you get one of those, you can go back to any of the equations then and find one of the other variables, then find the other variable.
Yeah. Okay. So then z equals -2.
Okay, I agree. And then what about y?
And then with that, we get y equals y equals 4.
Okay. And so again, kind of good to check
Yeah.
check them in one or the other, or all of them, especially if they're not too difficult to do. which is the case here, but those look correct to me. All right, any questions on that before we move on to something else?
Negative.
All right, so 18 is something we looked at, I think, a couple weeks ago. Really, you really want to look at this as 0.0010 plus 0.000056 repeating,
Mhm.
and create two fractions from this. The one on the left should be pretty familiar to you. It would be 10 over,
1000.
yeah. This one on the right, a little bit harder. You could also rewrite it as 0.56 times 10 to the minus 4. And then the
Yeah.
5/6 becomes 56 over 99 times 1 over that. Yeah.
Yeah.
And what's neat about the modern, tools we've got is you can always go to Desmos and make sure like this actually syncs up with what you want. You can play around with the numbers. Although most computers and calculators are really, vision's really tough on computers and calculators. You kind of have to do it like the top part and then the bottom part, make the kind of manipulate the numbers. The calculator will fail sometimes when you get large numbers like this.
Mhm.
But this one I think you can still do because you can multiply, by 99 over 99. That matches, that gets the 99. And then you can do a 10 over 10 to get to 10,000.
That equals 2489 divided by 247,500.
Good. I'll take your word for it.
Understood. Great responsibility, eh?
All right, we haven't done problem like 25 in a while. You mentioned these being ones that you struggled with a while back. So
Yeah,
let's take a look.
probably one of the first questions first meetings we had.
Yeah, I would agree. This is a good question because there's no y-intercept. The y-intercept's way over here, so it's kind of like you get something that doesn't look right. But I recommended drawing a line or picking some points to that kind of roughly, something that roughly works. Maybe that's not quite good enough. I don't know if you draw on your book or not, or can, but you really want to pick something nice though, like maybe that point and maybe, that point. I mean, you really want nice points. You don't want to be estimating
Mhm.
too hard there.
Okay.
So estimate those points and then determine the slope for them, please.
Alrighty. Okay, so the points would be 85, 400, 105, 800. And for the rise, okay. Okay, so that's gonna be 20, so y equals 20.
Slope is 20.
Yep, yep. Get that, and the intercept is, oh. Oh, how do I do that again? I don't remember.
So your slope is 20, like you just said there. Y equals 20x plus b. Use
Mhm.
one point or the other to find the b value.
Hmm. forget how to get the B.
Okay, so which ordered pair are you going to use? The one on the left or the right?
One on the left, I suppose.
Okay, so 400 x comma y, 400 equals 20 times 85 plus b. So you have to
Ooh.
multiply 20 by
Mhm.
85, which, you look at it and you're like, huh, like you're like, wait, where's my y-intercept? Well, again, this thing isn't scaled well. It's way down. I mean, you can't even see it there. So 170, 100. Yes.
Yeah. Okay.
So B ends up being minus 1300. Remember,
Yeah.
like this is not, zero's way over here. The graph's, going way down, way down.
Oh. Okay.
All right, almost there. So what else do we got? All right, let's do 29. I think we can do 29 on the time that we've got here. All right, so to factor, you really want everything on one side of the equation. So I'm going to move that minus 7x squared to the left.
Mhm.
And the first type of factor you always do is GCF. In this case, there's an x and everything. So you have 5x squared plus 7x plus 2 equals 0. Because it tells you that you can factor, you don't have to go to like quadratic formula or something, but you do have to recognize that the leading term is not a 1. So it's a special thing you do here. You take the 5 and the 2 and you multiply them together to get 10. And you look for two factors of 10, two things that multiply to 10 but add to 7. That is 5 and 2. And you split this 7x into 5x plus 2x. And then you factor by grouping. These first two terms become 5x, x plus 1, x plus 1 plus 2 in the middle, because that gets you back to 2x plus 2. And then you factor again. You factor out the x plus 1 that's in both, and then the 5x plus 2. And you set everything equal to 0. You set x equal to 0, x plus 1 equal to 0, 5x plus 2 equal to 0.
So x equals 0, -1, and -2 divided by 5.
Yes. Yes. And you can see that it does work out kind of nice. They
Mhm.
made it a little more complicated. So all right. It's probably gonna do it for today. We didn't
All
get through
right.
as much, but we got through a lot of stuff here. Let me go ahead and stop the recording. All right.
Yep.